Morning. Go ahead and begin. My name is Doug Purdy. I'm a technical evangelist with the developer division here at Microsoft Corporation. Our team is responsible for the development of Visual Studio and the .NET framework. The purpose of today's discussion is to provide you an overview of the .NET framework, tell you a little bit about exactly what that is, talk a bit about the design goals of the .NET framework, as well as provide you some insight into what we think are some fundamental key advantages that are present inside of the framework as well. .NET means a lot of different things to a lot of different people. And hopefully what I'd like to do here is to clarify kind of what the .NET platform is, the .NET vision is, and then we're going to drill into the framework and talk about where the framework sits in relation to all of those pieces. So on the slide, you see the whole of the .NET platform. And at the center, you can see that circle that is divided between clients, servers, and services. And those are the fundamental roles that each of our products play inside of the entirety of the .NET platform. So at the top, you see clients, which are Windows XP, Windows CE.NET, which we recently just released, and Office XP. To the right, Windows.NET Server, the reason you all are here, and the .NET Enterprise Server, SQL Server, BizTalk, things of that nature. And then finally at the bottom are what we call base services, commonly known as Hailstorm, or now retitled to .NET My Services. Passport is a piece of that. So these products in their entirety represent the .NET platform. And if you notice, right at the center of that circle is Visual Studio.NET. Visual Studio.NET is a tool that binds each and every one of these particular pieces of functionality into a cohesive whole. It is the tool that enables you to customize business behavior, to build the types of applications that you need to run your enterprises and to service your customers. And the .NET framework is a fundamental piece of that Visual Studio.NET product, as well as a standalone product that you can utilize to run .NET applications. So what do we think is the big deal about this .NET platform? I mean, why do we think it's a big deal? What value add does it really provide to you? Well, we think that you can categorize that into three different pieces. One, native XML web services architecture. We truly believe that the way that applications will interoperate and the way that systems will interoperate with one another is via XML web services. We believe that that really provides the type of functionality that you need in order to tie your applications together. And so every piece of that .NET product suite that you saw is integrating XML web services at the core. And the .NET framework is a fundamental piece of that. The second piece is developer productivity. This is core. This is central. If we cannot enable our developers, they will leave our platform. If we cannot enable you to build your applications in a robust fashion, in a quick fashion, it's just not worth your time to utilize the platform. So we're taking the largest developer base in the world, and we're giving you tools that you really need to run your business. And the final piece there is operational excellence. And in essence, what we're talking about is staying up all the time, 24/7, and having the ability to manage those applications throughout the lifetime that you're actually running them. Automatic health monitoring, transparent application recovery, restarting processes, things of that nature. So these three things in combination with one another are really what we think are the compelling advantages of the .NET platform. And as part of that, if we just drill into the .NET developer platform in and of itself, it's really comprised of two different things. One is, of course, the Windows operating system, the reason you're here at this conference. So Windows.NET Server will ship with the .NET framework baked in. And what that means is when you install Windows.NET Server, you get this fundamentally new and radically new development environment from the get-go. We just RTM'd the .NET framework and Visual Studio.NET, and then it's actually going to be released February 13th at the VS Live in San Francisco and at a host of locations throughout the world. But this is a fundamental piece of Windows.NET Server, baked into the box. And as part of this, there's also Visual Studio.NET, the premier development environment. I think anyone who's actually tried a bunch of IDEs would probably, hands down, probably say that Visual Studio is one of the best IDEs in the world. I do want to point out this, is that there's nothing that requires you to run Visual Studio.net to develop .NET applications. The .NET framework, and we'll talk about this in a few moments, provides all the compilers. It even provides a debugger. So you don't necessarily have to go out and buy Visual Studio.net, but I definitely would encourage you to do that. It's by far the most tremendous developer productivity tool that I think we've ever produced. Okay. So now I've talked a little bit about kind of setting the stage. We've talked about what kind of the .NET platform is, what are some of the compelling advantages of it. We've talked about Visual Studio.net and how it provides this developer productivity. So what I really want to talk about, and kind of the whole purpose of this talk, is to drill into one fundamental piece of this .NET vision, which is the .NET framework, and talk about exactly what that is, what the design goals were of that, and then talk about some of the features and functionality of it. So before we begin this talk, I kind of want to talk about the design goals, kind of provide you some guidance into what we were thinking, what we were trying to achieve, and that'll be the framework for our discussion. So when we sat down and we were designing the .NET framework, these are the top 5 goals that we were trying to achieve, and we think we've nailed each and every one of them. Number 1, we really needed to unify the programming models on Windows. I don't know how many of you are actually Windows developers, but you know there's a whole host of ways of programming for the Windows platform. You have the Win32 API. You have MFC. You have ATL. You have Ruby forms inside of VB. There's a whole host of different mechanisms that you have to build applications. And you know what? We think all of them are good to some extent, and some of them are bad to some extent. And it was always pretty much incumbent upon you to determine which tool set actually fit the bill for your application. So it was very, very difficult sometimes to provide prescriptive guidance to folks. So we wanted to eliminate that. We wanted to provide consistency in the programming model. Number 2, we were really looking to simplify development. Because of the legacy growth of the different APIs that are built into Windows, you saw a lot of need to generate a tremendous amount of plumbing to interoperate with these different types of frameworks. In addition, if you really look at COM has a tremendous amount of plumbing that you need to manage. You have to manage GUIDs, you have to manage type libraries, you have to manage all these different types of things that are above and beyond what you need to do as a developer. Right? You have to worry about these management and deployment issues, which you really shouldn't have to do. So we really wanted to simplify that model. Number 3, we were really looking to provide a robust execution environment. Okay, and what I mean by that is this, is managed services, providing you automatic garbage collection, providing you verification that your code is safe. Things that are above and beyond the typical types of services that you get just from running right to the metal, right to the CPU, or right to the operating system APIs. The 4th thing is absolutely critical to our design goals. If any of you have actually programmed in COM, you know that we've always supported multiple languages via that mechanism. VB could talk to C++ components. C++ components could talk to Delphi components. It was a binary standard anybody could interoperate with. We wanted to continue that legacy. We truly believe that one programming language cannot solve all problems. If it could, we would all still be coding in COBOL or assembler, right? Languages evolve. Different problems can be solved more succinctly in different languages. A great example that I always use is matrices. Would I necessarily use Perl to manipulate matrices? Probably not. I probably want to use a pointer-based language to do that. So we truly believe that multiple languages have a very important role in many applications. And in fact, I believe, if I recall correctly, there was a recent study that was done that talked about developers typically use 3 different languages on any given project. So we wanted to continue that support. And then actually 5th and finally is XML web services. We truly believe that XML services, as I said at the beginning, is a way to get interoperation, the way to have applications talk with one another. And so we build XML web services as the absolute core of the .NET framework. Okay, so this is what it looks like. This is sort of the stack, as it were. And we can drill into this. This is going to be the framework of our discussion. We'll drill into each and every one of these items to give you an overview of exactly what features and functionality are provided. It's important to look at the bottom. Windows is the core. Windows is the operating system in which this entire substrate is a substrate for the entirety of this stack. So it sits at the bottom. And then there's a thing called the Common Language Runtime, and we're going to drill into that in just a moment. And above that is our base class libraries. Above that, ADO.NET, which is the second generation of data access, the second generation of ADO. Above that, ASP.NET, the second generation of ASP. Windows Forms, which is the manner in which you actually do client UI inside of the .NET framework. And then above that are all the different languages. There's about 24 languages that we support on the Common Language Runtime, and we're going to talk about those. And of course, to the right-hand side is Visual Studio.NET. That's the core tool that you can utilize to build and bind all of these together. So let's just examine the Common Language Runtime. Okay? Those of you that have a Java background, this would be somewhat analogous to a Java virtual machine. Okay. So let's kind of talk about the evolution to this Common Language Runtime. How did we get to that? Well, first off, if you look at this slide, you really see that before COM, applications were kind of these silos, kind of sat out somewhere on some system and really couldn't talk to one another. There was no way for you to reuse the functionality typically. Now, how you did get reuse in a lot of these different scenarios was you actually you had both applications talk to the same database, and that's how you could get some data sharing. Or you did some type of database operations where you would actually move data between databases so systems could access the different sets of data. So, in essence, they were separated. And then COM came along. And COM gave this really cool way for you to have different components and different applications on different systems and on companies across the world to actually interoperate with one another. It gave this really nice way for you to reuse your functionality, where you didn't have to reinvent the wheel every time. Your reuse wasn't just copy and paste. So COM solved some of those problems. The downside to COM is there was a tremendous amount of work that you had to do to provide plumbing in order to make that happen. Okay? If you're a C++ programmer, you know well about this. If you're a VB programmer, we did a pretty good job of abstracting you away from it, but if you've ever deployed your application, you've probably felt a little of the pain that is there with COM. Okay? So COM solved some problems, but it created others. So .NET really is a response. We definitely wanted to keep the COM functionality, the ability to have all these components talk to one another. But what we wanted to do was solve this plumbing issue. And another thing, too, about COM is there was no way to do implementation inheritance inside of COM. There was no way for me to write a given implementation, let's say class A, and then build in one language, and then build another class, say class B in another language, and have it inherit the behavior. There was no way for me to do that because COM was a binary interface standard that did not allow implementation inheritance. Well, .NET, number one, removes all the plumbing. The .NET framework removes all the plumbing that was required for COM. In addition, it provides me the ability to have implementation inheritance. So now I can actually extend behavior from different components in my system. And we're going to talk about how you do that. Okay. So let's talk about plumbing. Let's talk about the things that were eliminated from COM, because I think it's critical that you really understand the deltas between these two environments. So in COM, you had to register your component with the registry, right? So you built this component, and then, assuming that it was self-registering, you would run regserve32, and it would inject a whole bunch of stuff into the registry. That's gone. Every application inside of .NET is self-describing. You can actually ask that application, what do you do? What functionality do you provide? There's no need. The registry is a thing of the past. You do not need that for .NET applications. The next thing, let me back up one. GUIDs, globally unique identifiers. Actually, if you're familiar with the DCE standard, this is UUID. At Microsoft, we take a smaller view of the world. So it's a globally unique identifier, not a universally unique identifier. But you used to have to generate these things and append them to your IDL. And when you actually registered, this is the key, right, the unique key that you utilize for your component. In VB, you didn't really have to worry about this. It was kind of abstracted for you. But needless to say, it's gone now. There is no need whatsoever for GUIDs. We have a system now of hierarchical namespaces of types. So you have unique names. And even if something was named the same, we have a thing called a publisher key. We actually utilize public key encryption to provide a unique name. So there's no need for a GUID. IDL files. This was the way that you described your interface inside of COM. This is the way one component knew about the other components type of functionality. That's actually gone now. There's no need for that because we have a unified object model. I'm going to talk about that. H results. If you're a VB programmer, you really didn't see this. In C++, you're very familiar with what an H result is. This is actually the return value of almost every single COM function. In fact, there are only two that I know of that don't return H result, and that's on IUnknown. But H results, those are completely gone. Now you have structured exceptions at the runtime level, and those can bubble up from one language to another language, or from one component to another component. IUnknown. Those of you that did C++ are probably very, very familiar with this interface as being the root. Every interface inside of COM had to have implemented IUnknown, right? It had to actually provide an implementation of that. That's actually gone. There's now an object that every single object in the system inherits from, and it's called system object, and we'll talk about that. Add ref release. This was the way that you did memory management inside of COM. This is how a component knew whether or not it was being used or was notified that it wasn't being used any longer, and then the component could clear up the memory. That's completely gone now because we have a built-in garbage collector. You are no longer responsible for memory management at all. You create instances of objects, and then you just are done with them. That's automatically cleared for you. And then finally, co-create instance. This was the way in which you could create an instance of a COM component. That has been completely replaced by the new operator. So in every language, there's actually a representation of this new operator that will actually create instances of objects for you. There's no need for you to actually call this API call at all. So as you can see, there are some fundamental differences between what you used to do or what you still may be doing today in your development environments and what we have now in the .NET framework. So continuing on with simplifying development, we developed this common type system. And what that means in essence is that throughout the .NET framework, the type system is exactly identical. And this allows me to have implementation inheritance because every single object in the system extends from system object. So in essence, it provides me an entirety of objects that I can add to by extending from system object, and allows all the different languages to interoperate with the same type system. Those of you that were familiar with COM know about OLE automation, and you know about the different types that were exposed, beaster, safe array, things of that nature. In essence, this eliminates all of that. This provides a very clean and consistent way for all types to be described throughout the .NET framework. And then the final piece here is a very clean OO, object-oriented programming model. So there are things such as classes, such as interfaces, constructors, properties, methods. All of those things are first-class citizens inside of the .NET framework. If you're very familiar with COM, you know this wasn't necessarily the case. Actually, you had no idea what classes were actually being utilized inside of COM before. You knew what the interfaces were, you knew what the methods were and the properties were, but that was it. You really had no insight into what was going on inside of that component. And so what this enables, this common type system and this clean object-oriented programming model, is this cross-language inheritance that I'm talking about. It's a wonderful thing, and we're going to drill into that just a bit. Okay. So in .NET, everything is an object. Okay. And let me talk about why that's important. If you're a C++ or Java programmer, if you've ever programmed in any of those environments, primitives are magic. And what I mean by primitives is I mean ints, doubles, booleans, these very primitive data types. There's some kind of magic in C++. They just work. Okay? In Java, they're the same thing. They just work. Now, in Smalltalk and Lisp, if any of you have a background in either one of those two languages, every primitive, every int, every double, every boolean is actually an object. You can actually send it messages. You can say, hey, object, what's your name? Hey, what's your value? Hey, why don't you transform yourself into something different? Right? This very, very powerful object-oriented programming model. So if you look at C++, you look at Java, the reason their primitives are kind of magic is for performance reasons. It's very, very important. Primitives could be very, very expensive depending on how they're represented. So that's why they're kind of magical. In Smalltalk and Lisp, they're objects, but you pay a tremendous performance penalty for doing that. In .NET, we actually unify that. We give you all the power of Smalltalk and Lisp at zero performance cost, at the performance cost of C++ and Java. So it's very, very, very powerful. And what this really means is very, very deep simplicity in the system. And in essence, what that means is you don't have to worry about necessarily what type an object is. You don't have to worry if it's a primitive. You don't have to worry if it's an object. You can just treat them all the same. And that's very, very powerful for developer productivity. If you're a C++ developer, you know the value of this. And if you're a Java developer, you definitely know the value of this, because you're doing a lot of different things to treat integers like objects inside of those languages. And this actually improves the extensibility and reusability inside of .NET, and it allows you to create your own primitive types. Let's say you're not happy with our integer. Yeah, you really don't like it. You know, those guys at Microsoft, they're smart, but I like my own int. Well, you can build your own int. You have that power. You want to build your own int? Have at it. You want to build a decimal type? Have at it. You want to build a money type? Have at it. And it will be as equally efficient as an integer or as a double or as anything that we have. Okay? So that's a tremendous amount of power for you. Tremendous amount of power. And one of the fundamental keys is collections work for any kind of type. A great example of this is, say, in the Java programming language. If you have a hash table and I would like to put integers inside of a hash table, I cannot really do that. I actually have to create a whole bunch of objects called integer objects, put my int primitives inside of that, and then put them inside of the hash table. So that is a lot of overhead for a programmer. In .NET, you don't have to worry about that. Since every int is an object, you just put it inside of the hash table. So it's a very, very clean programming model. This is a thing called boxing and unboxing. Let me talk about that. This is actually that scenario that I was just referring to with the hash table. In .NET, if you look on the screen here, you'll actually see some code. And you'll see that we're actually creating an integer, and we're giving it the value of 1, 2, 3. And then the next line, you'll see that we're actually assigning that integer to be of type object. So this is showing the power of the .NET framework, where I can refer to anything in the system as an object. So the code on the left is actually VB.NET code, and the code on the right is C# code. So you can see the different syntaxes. But they are the same exact thing. When it gets all compiled down, it becomes the same thing. So, and then if you look again, I'm now taking that object and I'm putting the value of that object inside of another integer. So in essence, what you see that I'm doing here is I'm creating an integer, a primitive, and then I am taking the value of that, putting it inside of an object, and then I'm taking that and sticking it back inside of an integer. Now in Java, I would have to have at least the creation of another object, another line there to create another object. And I couldn't even do this in other languages. It would be impossible for me to actually do this. And actually what this will do is, if you look down here at the bottom, you actually see what's going on inside of the system. Inside of the system, the integer is being created. It's actually on the stack. So that over to the left is the stack. And you see the integer 1, 2, 3 is actually on the stack. And then you see when the second line gets executed, there's actually an object being allocated on the heap, and the value of that integer is being placed inside of it. And we call that operation a box. In essence, what's happening is we're going up to the heap, creating an object for you, and putting that integer value inside of it. And then the second piece that you see there is us actually taking that value off the heap and putting it back on the stack. And that's commonly known as unboxing. So this is something in other programming languages that you have to be responsible for. You're the one who has to manually go in and write the code that does all this. In the .NET framework, we just do it for you. It's just automatic. You treat everything like an object. That is fundamentally core. Everything is an object in the .NET framework. Everything.
Question here.
Yes?
Are you taking questions?
Yeah, I'll take questions, please.
Yeah. Now, so you're saying object O. So does that create O on the stack, on the heap?
No. O. All right. An object is always a reference type, so it will be on the heap.
Okay.
So O will be created on the heap, and then you're assigning the value of the integer. So in essence, what is going to happen is this object will be heap allocated, and then the value of that integer will be copied into the heap object, and now it's an object.
Now my question is, if I just say object O, does that instantiate an object?
No, that will not instantiate an object.
Just create a reference.
It'll just create it. Actually, it won't do anything. You're just allocating, right? You're allocating something on the stack, but you're not actually creating something on the heap at that time.
Yes.
Yes.
So are you saying that the int I and j are treated a little differently from the object O in the terms of allocating on the stack?
Yes, yes. All what you would call primitives inside of .NET are always stack allocated. Always stack allocated. And that's where we get the tremendous amount of performance. When you want to start treating it as if it's an object, we will create a copy of it on the heap for you automatically. Now, another thing that we will actually do is you can actually create objects in line on the stack, which is something no other execution environment supports. So you could create any type that you wanted and keep it on the stack. You can do that as well. But in this scenario, it would actually be moved up to the heap. And then you could treat it as if it was a reference type. And then if you wanted to treat it as if it was a stack type, you could certainly do that as well.
Let me just understand what you just said last. So you're saying objects can also be created on the stack?
Just like C++, correct.
Right. Now, if anything is created in the stack, I guess when the particular method exits, then they are just cleared up. They're garbage collected.
Well, the garbage collector will determine when the correct time is for it to be garbage collected. If it is stack allocated once it gets popped off, yes. But if it is on the heap, then the garbage collector takes care of that. Okay. So the next piece is a robust execution environment. So talking about garbage collection. Garbage collection in essence means this. You don't have to worry about memory allocation. I don't know how many of you, well, let's save them until the end if you don't mind. Okay. So garbage collection is in essence saying this, that I'm going to allocate I'm going to actually allocate memory, and then I'm not going to care about it. I'm going to let someone else worry about that. I don't know how many of you actually are C and C++ programmers, but you know that memory leaks are one of the most atrocious problems in the world. Trying to track down what's going on. Those of you that do systems operations know half the time when you have to restart processes, it's because there's a memory leak, right? This eliminates memory leaks. This just gets rid of them. In essence, what happens is the programmer says, hey, I want to have some memory, and then they say, okay, I'm not going to worry about it. I'll let the system clean it up. And so we have a very, very, I won't say complex, but garbage collectors are a well-known technology. We think we have a really world-class garbage collector that does a really good job of freeing up memory. So that's critical to this execution environment. The next piece is exception handling. So error handling is first class and mandatory. Okay? Actually, what will happen is if you don't actually handle an exception, the process will crash. And so that's very, very important for especially server things because it's better to be dead than it is to have incorrect results. Right? You obviously don't want errors to happen inside of the system. So a wonderful thing about this is I can write something in, say, C# or C++, any given language, and if an error happens and, say, VB is actually calling that component, I actually will get an exception inside of VB. It's really, really cool. I don't have to rely on Boolean values. I don't have to do any of those things. It's very, very simple. It's a unified model that spans all languages. It's actually a very, very cool feature. Another piece is type safety. What this means is the elimination of buffer overruns. Those of you that are familiar with some of the security issues on a lot of different operating systems know that one of the great exploits is overrunning a buffer, right, and inserting code into that buffer. Type safety eliminates buffer overrun. And in fact, in .NET, strings are immutable. That means they cannot change. It is impossible to change a string inside of .NET. And that's absolutely critical to preventing those types of security issues that have happened. Then finally, deployment and management. Assemblies and side-by-side execution. The unit of deployment inside of .NET is a thing called an assembly. An assembly, I could go and drill into exactly what the logical meaning of that is, but you can think of it as a DLL. It's as simple as that. So, but we don't call them DLLs any longer. We don't call them exes. They're just called assemblies. So that is a unit of deployment inside of .NET. And the work that we've done with these assemblies is such that you can do side-by-side execution now. There's nothing that prevents you from installing different versions of different components on the system at any given time and just have your applications work. This was commonly known as DLL hell, right? You installed application A, you installed application B on top, and boom, right? Application A doesn't work anymore, right? Horrible, horrible condition to be in. Windows 2000 did a good job of cleaning a little bit of that up. You could do the local, right, with the exe, and it would actually pull files from that directory. But this completely eliminates it. .NET is absolutely wonderful at doing side-by-side execution. .NET Framework Security. This is also a really cool feature of this environment. It's an integrated security environment. Security is designed throughout the entirety of the framework. As you know, in Windows 32, security was pretty much based upon who you were and what group you belonged to, right? That's pretty much how you manage security in the system. Inside of .NET, that's actually not the case. So inside of Win32, I either have permission to run the executable or I don't have permission to run the executable. And if I do have permission to run that executable, I can do anything I want, right? Anything. If I can run that exe, whatever that exe does, I can do it. Inside of .NET, it's not the case. Each and every operation, it's very, very fine-grained. So now you can actually control whether or not someone inside of an executable can read a file. You can actually control whether or not someone can access a network resource. You can control whether or not someone can even draw on the screen. Very, very granular security. Very granular. And what we call that is code access security. So you'll hear this phrase a lot. This is really going to be part of the Microsoft security effort, is code access security. It is based upon a runtime security policy. So you as an administrator or you as a developer can control very granularly what your application will do based upon who's actually executing it. And all of this is configurable. Every bit of it is configurable via an XML file. It's configurable by application, by machine, and by enterprise. So you can actually define policies at an enterprise level and deploy that out, and everyone actually gets that code access security policy. It's a wonderful programming model and a wonderful administrative model as well. ASP.NET. I'm actually giving a talk as a little plug for another talk I'm giving tomorrow on ASP.NET. ASP.NET is the second generation of the way you build web applications and web services. We provide a tremendous amount of authentication capabilities inside of that. You have the ability of authenticating against your Windows identity, so whatever happens to be in the SAM. You also have the ability to authenticate against Passport if you'd like to do that. You can do forms-based authentication. We also have the other forms of authentication that you can do as well. Pretty much anything that IIS supports will actually do that authentication as well. And then finally, there is a cryptographic library built in, so you don't have to go find a whole bunch of algorithms to do encryption and hashing and all these different things. We build that into the framework, and we do support the digital signature initiative for XML. So that is built into the framework as well. And those of you that are worried about web services security, these are some of the pieces that you can start to realize some type of security framework for that. Okay. Multi-language platform. As I said at the outset, the fourth design goal that we had was the ability to have all these different languages all talking to one another and taking advantage of implementation inheritance. The .NET platform is completely language neutral. Okay? I know a lot of people have talked about, well, C#. The only way to code for the .NET framework is to code in C#. Or maybe VB. That's not true. You can code in up to 24 different languages for the .NET framework. And if you'd like to write your own, come and talk to me afterwards. We'll talk about it, because there's nothing that would stop you from writing your own language that would run on the .NET framework. The list is extensive. You actually look at the bottom. COBOL, Eiffel, Fortran, Perl, Python, RPG, Scheme, Smalltalk. There's a whole host. If you did a language in college, if you did a language, I don't know, in your last job 10 years ago, chances are it's supported on the .NET platform. There's no reason for you not to be able to use your favorite language of choice. And they're normally first-class citizens, or they all are first-class citizens inside of the framework. There is a distinction between what we call an extender language and those that actually utilize the framework. But the majority of those are extenders. And if you look here at the languages that we're actually providing, we're giving you VB, that's in Visual Studio.NET and in the framework, C++, C#, which you've probably heard quite a bit about, J#, which is a bit fond of my heart. This is our Java language product. So we do have a Java language product for the .NET framework, JScript. So we're providing all of those different languages. And then third-party vendors that we're working very, very closely with are providing those languages that you see at the bottom. This is critical. I think this is really critical to our success as well, because we do, as I said at the outset, truly believe that you should be able to program in any language whatsoever and have it be a first-class citizen and take advantage of all of these things that we think are wonderful about the .NET framework. And one interesting thing I just highlight, I don't have a demo of this, but in Visual Studio.net, you now have the capability of having a whole bunch of different components written in all these different languages and actually have them stepping through. And so for debugging purposes, it's absolutely amazing. So I'll actually be doing C++ code, and I'll step through it, and it'll automatically jump into VB code, and then I'll step through that and automatically jump into C# code. It's absolutely wonderful. So let's talk a little bit about how this execution environment actually works. I'm not going to belabor this because we could get into this for hours and hours and hours. I just kind of want to show you at a very high level exactly how this works. So when you first start off utilizing the .NET framework, you code in one of those 24 languages, right? Whatever it is, whatever suits your fancy on a given day, you sit down and you write in that code. You write that code out. You express your intention in that language. So now I have my source code. So then I take that source code and I run it through a language compiler. Okay? I run it through the C# compiler, I run it through the J# compiler, I run it through a C++ compiler. That's what I do. Standard procedure that you're always typical with. Now where it's a little different is this. What I get out at the end of the day is a thing called an assembly. It's not a DLL, it's not an exe, it's what we call an assembly. It may have a DLL extension, it may have an exe extension, but we call it an assembly. Now here's the fundamental difference. That's actually not x86 code that you're used to seeing. It's actually what we call IL. And that stands for intermediate language. Intermediate language is a language for a virtual, meaning it doesn't really exist, abstract stack machine. So it is kind of a language that programs, in essence, a specification. So it's a language that's actually stack-based, so everything is push and pop, push and pop, push and pop. But it's not x86 code. Not x86 code at all. In addition to the code, you actually have this thing called metadata. And in essence, what metadata is it's data about data. So it's data about your code. So this replaces all that kind of plumbing that you used to have with COM, the GUIDs, right? The need for registration, all these different types of things. We replace that with a thing called metadata. And those are all encapsulated in one file. You don't have to worry about the registry. You don't have to worry about a type library. You don't have to worry about any of those things. It's just one file, an assembly. Okay? So now we have this assembly. It has our IL code. It has our metadata built inside of it. So how the heck do I get the thing to run on my x86 machine? What happens? How does it work? Because my x86 certainly doesn't understand this abstract stack machine stuff Doug's up here babbling about. How does it actually run? Well, it runs through a thing called a JIT compiler. All right? JIT stands for just-in-time compiler. Okay? When you run that executable, rather that assembly, I still haven't quite caught up to the new terminology. When you run that assembly, when you run that .NET application, the system sees that this is IL code. It knows that it really can't run. It knows it can't do anything. So it invokes this jitter. Okay, this just-in-time compiler that reads that IL code and translates it on the fly to x86 code and then executes it. Now you may be saying, whoa, isn't that slow? That sure seems like an awful lot of overhead. All right? True, right? True, it may seem like a lot of overhead, but I think you'll see that there's a lot of benefit to doing it in this manner, and the performance impact is not quite as bad as you would ever think it would be. And here's why. One of the cool things that you can do with the .NET Framework is, when you deploy your assembly, you can actually JIT it at the time that you deploy it. Okay? So there's no performance cost when you actually run the application. When the user double-clicks on it, this jitter doesn't have to run, because you ran it when you installed the application. Okay? And we call that, there's a tool called NGen, and that's native generation. And so that will actually build this native code for you automatically when you deploy it. And actually, when you install the .NET Framework, the majority of the framework gets compiled when you deploy it. So there is no real performance cost for you to actually utilize this JIT compiler. Now, one of the fundamental benefits of the JIT compiler is it is conceivable that the JIT compiler could actually be faster than static compilation that you're used to. And let me explain why that is. Let's say you're a developer, and you have a development machine, and let's say it's a 766 Pentium 3 or Pentium 4. And you compile your code and you hand that off, and the administrators actually deploy that. Now, I'll make a big guess that the machine that you're running that code on is going to be a lot different than the machine that you actually compiled it on. Right? The machine that you're running on may be this monstrosity. It may be a 32-way processor, right? Maybe an 8-way, maybe a 4-way. It's probably a lot different, has a lot more memory, has a lot more different characteristics than the development machine had. Well, this JIT compiler is aware of the environment in which it's in. So it can do optimizations based upon the environment that it is in. Whereas if you're just taking something that was statically compiled and copied it over, it knew about the old environment. It didn't know about the environment it's actually going to be executed in. So that's one piece. Another piece is the fact that we do this JIT compilation enables us to do things like security. It enables us to do things like verifying that something is safe to run. Because if you actually compiled it and then just copied it over, there's no way for us to get in between the code executing and finding out whether or not it might be dangerous. For us to go in there and actually look at the code and determine what the heck is going on. So this provides us a way to have someone in the middle of that process saying, whoa, let me look at the code first. So this JIT compiler actually, this process, is responsible for ensuring that security actually works in the system. And that is a very, very valuable thing. The performance costs, potential performance costs, we think the trade-offs, the performance benefits, or not rather the performance benefits, but the benefits that you get of having this type of environment outweigh those costs. And at the final analysis, if you just want to JIT compile it when you deploy it, feel free. So that's how this works. And this is at a very high level. If you want, we can take this offline and we can talk about it until I'm blue in the face on exactly what goes on at a deeper level. So as I said, assemblies, these are the units of deployment inside of .NET. They're self-describing. They contain all this information about your code, so you don't have to have a bunch of other files that actually describe your code for you. So it's a very, very clean model in terms of deployment. Assemblies are also the unit of versioning inside of .NET. So you version assemblies in a way that you used to version DLLs, but it's a lot less granular, a lot more granular than that. Also, assemblies are boundaries, security boundaries. So security inside of .NET is done on an assembly-wide basis. So in essence, assembly by assembly. And then types or classes inside of the .NET framework are always named relative to the file that they're actually in. And this allows us to have the same name occur in many, many different files. And everything is relative to the actual type, to the actual assembly. It's just important, I guess the key takeaway here is this, is that assemblies are this new way of actually deploying applications. They look like DLLs, they look like exes, right? And in fact, they have those extensions. But they're a lot different than your traditional x86 exe. They actually don't contain x86 code. They contain IL code. They contain this metadata that we talked about. And they're units of deployment, they're units of security, and they're units of versioning inside of the .NET framework. And it's important to bear those in mind. Zero impact install is critical to deployment and management. And this is what we mean by this, is the ability to X-copy. You've probably heard us talk about this all day long and for years and years and years. The ability to take a file, copy it up to the server, and it just works. To deploy a web application by saying X-copy. To not need to go and unregister something, reboot the server, re-register something, copy this file up there and register it with the registry. All that is gone. The .NET framework, you can deploy applications simply by copying assemblies into file directories. The wonderful thing about this is you can do that for running applications. ASP.NET provides the functionality of having a web application that has users hitting it right now, and for you to take a new piece of functionality, a new set of code, and copy it up to that server, and it doesn't impact the server at all. It just keeps working. Just keeps working. And that's critical. And another one is side-by-side execution. The ability to have multiple versions of different assemblies or different applications running without impacting anyone else. And this is built into the system as well. It's a wonderful piece of functionality. The nice thing about this is you can actually have multiple versions of different components in the same process. Think about that for a second. Could you imagine trying to do that with what you have in Windows 2000? It's a wonderful feature. Okay, so I'm actually going to show a demo of something pretty cool. This is called Terrarium. Some of you that came in just before the session began probably saw this. This is actually a .NET application. It utilizes a thing called Windows Forms. So you can see you can actually write games in the .NET framework. You know, if you want to do that, that's great. This actually utilizes Windows Forms and uses DirectX, which is our gaming or 3D kind of gaming API that's very popular with the Xbox crowd. And so this is a game that everybody in the developer division pretty much runs. Okay? And it's not like we goof around and we're not really, writing software. This actually serves a useful purpose. And the useful purpose of this is a peer-to-peer application where a developer can go in and actually create animals, create plants, and populate those animals inside of this world. And this world is called the terrarium. And so you can actually see this is running live. I'm actually on a peer-to-peer network. None of these creatures are running on my machine. Well, they are running on my machine, but none of these are actually here on my machine. This utilizes a thing called mobile code, which is another feature of the .NET framework. We're going to actually have code executing on multiple different machines. It's a wonderful feature, and it really enables powerful peer-to-peer applications and what we call smart clients as well. So this is just kind of a flavor of some of the things you can do with the .NET framework. And I'm going to show you really quickly a way to build your own creature. I'm going to create a little world here, and then we're going to come back and see how we're doing. And in essence, this tool really provides a way for two things. Our geeky needs to create things. So you create this great creature, and then you can see how it does. And so you can actually see this is actually an evolutionary environment. So you can see how if your creature is successful, if it's going to live, if it's going to survive, it becomes extinct, things of that nature. So let's just really take a look at a creature really quickly. And I'm going to show you, this is some C# code, how really quick or how real easy it is to develop applications inside of the .NET framework. So in essence, this is some C# code. So it may be a little different than some of the code that you've seen before. It utilizes some things called a declarative programming model. And that's these things, if you look right here, these are called attributes. It's a declarative programming model. You don't actually have to write code per se. You can just kind of annotate things with an attribute, and it automatically gives behavior. So if you look there, you can see that I'm creating a carnivore. If you see this carnivore attribute up here, I'm actually going to create a carnivore to see how well he does, whether or not he can actually survive eating other animals. And it has a rather apt name. If you look down here, it's actually, if you guys are into J.R.R. Tolkien at all, this is the Balrog. So that's the guy that ended up killing Gandalf at the end of the movie, if you've seen that yet. I made this up last night, so it may not be that funny. So in essence, this is a creature that we're actually going to take. We're going to compile this down. So this is the source code that we showed just a few moments ago. We're going to compile that down into an assembly, and then I'm going to take that assembly and I'm going to load it inside of this application. And it's going to be just-in-time compiled, and it's just going to work instantaneously. I'm just going to point it at a file, and it's going to work for me. The wonderful thing about this, and one of the real purposes for this terrarium is for security purposes. Terrarium was this thing that was actually constructed, this world that you saw, that was actually constructed to make sure that no one could actually pull off a security exploit inside of the .NET framework. Because it has all this mobile code from other different people's machines running on it, if there was a security flaw inside of the .NET framework, I could potentially take over anyone's machine with my creature. Right? And this was a great way for us to test whether or not we had done our job. And guess what? No one's taken over my machine, so I must have done my job. Okay, so I'm going to create a real quick world, a brand new world here. And incidentally, you can actually download this from a website called got.net, and you can actually play this as well if you'd like to. And you can create your own creatures. There's actually a development guide that's up there that'll actually show you how to design your own creatures. And we encourage you to go up there, build your own creatures, and let's fight it out. You can build plants if you want to. So you can just have plants that kind of roam around. So what I'm going to do here, this is kind of an empty world. There's nothing in it. This little blue ball is actually what's called a teleporter. And what this does is this is central to moving different creatures across the system. So if an animal runs into this teleporter, it gets moved to another machine. which is a really cool feature as well. So that code just goes across. And this is the .NET framework in action. So I'm going to introduce an animal into this brand new world. And the name of this is Hungry Hippo. Now, that obviously isn't the Balrog that I just had before. I had to have something the Balrog could eat. So its name is Hungry Hippo. The cool thing about Hungry Hippo is written in VB. But the Balrog is written in C#. Okay? So this is showing that cross-language functionality. So I'm going to add a whole bunch of Hungry Hippos. You can see them kind of populating. Right? I'm just adding a whole bunch of them. And you can do this at home if you'd like. You can follow along. Now I'm going to introduce the dreaded Balrog. We'll see how they fare. And let me add some more Hungry Hippos because I have a feeling our Balrogs are kind of mean. So let's introduce a couple of those Balrogs, and if we can get a couple on the screen, you can see that they immediately, this is one here, you can see that they immediately start attacking the Hungry Hippos. So what they're trying to do is kill the Hungry Hippos and eat the Hungry Hippos, and this is actually it's a game like life. It's evolution, etc. So what we're going to do is we'll leave this running in the background. At the end of the talk, we'll come back and we'll see who's still standing, the Hungry Hippo or the Balrogs. We'll see. I have a feeling, since I programmed the Balrog, which one's going to win. So don't feel. I was kind of dreading actually showing that example because somebody might get offended. So I'm sorry. Don't kill the Hungry Hippo. Don't kill the Hungry Hippo. So I mean that's a pretty cool example. Okay, demo, great. All right. So we talked about the common language runtime. We talked about the Windows functionality. Now let's kind of move up the stack a little bit and talk about the core things that you're going to be interacting with. The base class library, ADO.NET, ASP.NET, and Windows Forms. Okay, so when we were designing this library that you're actually going to be utilizing, there were a couple things that we had in our mind. Number one was organization. We really, really wanted this to be very clear on how you actually are going to be building your system. What class do I use? Do I use the string? What string do I use? If you've ever done C++ code, you know how many different kinds of strings there are. Okay? And how to actually get them to work with one another is like a nightmare. So one of the things we wanted to do was eliminate that. So we wanted to have a very, very factored set of class libraries. The next piece is this unified type system that I was talking about, where everything is an object. We definitely wanted to take advantage of that when we were building the base class library. One of the core things is there's only one string type. Unlike C++, there's not a trillion of them. There's only one. And then all characters are Unicode. I don't know if any of you have actually felt the pain of Unicode support on other operating systems if you had to support international applications, but you know that it can be significant. And inside of the .NET framework, every character is actually a Unicode character, which is big. It's very nice. And then the third thing is the .NET framework is very component-oriented. Let me explain what that means really quickly. You've heard of object orientation, where you have different objects that talk to one another via methods and properties, methods. Component-oriented kind of comes from COM. And it comes from the fact that COM components had properties. They had events, right? Like is running, is clicked, right? You had these kind of functionalities. And you had attributes inside of COM as well. And we wanted to take those benefits and extend that into the .NET framework. So what we call that is component-oriented programming. So the .NET framework not only is object-oriented, meaning it has classes that have methods that you can do inheritance with, but it also is component-oriented, meaning that you can have events, you can have properties, you can have attributes on objects as well. So we think that that is fundamentally a benefit for developers as they go throughout developing their applications. And the final thing here is design time functionality. And in essence, what this means is the ability to have really, really cool designers, the ability to build applications like you do inside of VB. We really believe that the way that you build applications inside of VB should be the way that everyone builds applications, meaning that it should be easy, it should be functional. You should worry about the problem you're trying to solve, not spending time figuring out how to solve that problem. Right? How do I go about making this happen? Make my life easier, Microsoft. Just let me solve my problem. Let me look good in front of my boss. How do I do that? So that's what we're trying to do. So this design time functionality brings the ease of development that you had inside of VB to the web forms. And that's critical. So how much simpler really is this? I mean, Doug, you're talking, show me some code. Okay, fine, show you some code. The top window is how you create a window inside of the Win32 API. This is how you do it. If you're a VB programmer, you're like, whoa, what the heck is that? If you're a C++ programmer, you know exactly what this is. So in essence, what I'm doing is I'm creating an actual window class there, and then we're actually saying, hey, I'd like to show an instance of that window class, and then update that window class. The loop's gone. You actually don't see the message loop, which is a whole other set of nastiness that I don't want to foster on you guys. So as you can see, that's a lot to remember. Okay, it's a lot to learn. So in .NET, what does that look like now? If I want to do the exact same thing in .NET, what would it look like? Considerable difference. Much, much, much cleaner. We have abstracted out the entirety of all that stuff that you need to worry about inside of Win32 down to 3 lines of code. Now, if you're a VB developer, you're probably saying, well, I could do that before. Well, now everyone can do that. C++ developers can do this. C developers can do this. Smalltalk developers can do this. Java developers can do this. Anyone can have the same programming model. The same beauty and richness that you had in VB has now been extended to all different languages. The framework is not a black box. Those of you that have had to use COM components are probably very familiar with the fact that there was no way to extend functionality. We had a very, very rich control market, meaning that you could go out and buy a calendar control, right, an ActiveX calendar control. But let's say you weren't happy with the way that calendar control, displayed something. How did you change that? Well, you didn't. You lived with it, right? Because that was just the way it was written. .NET is not like that. If you buy a control from a control vendor now, chances are you can extend that. Inside of the .NET framework, if you're not happy with the way that we implemented a given class, you can change that. Almost every single class inside of the .NET framework can be extended. There are some exceptions, and the reasons that there are exceptions are for security or performance reasons. But those are very clearly demarcated. So there's no need to actually have to write a wrapper, for the most part, for any of these kinds of things. You don't have to do that. And the final thing, this beautiful thing that I keep talking about, is this cross-language inheritance. So you can buy a control from a control vendor that was written in C++ or that was written in C#. You can use it in your VB product, and you can extend it inside of your VB product. You can take a control written in VB.NET, use it in a Smalltalk project, and extend it from inside of Smalltalk. Right, very powerful. Web standards and practices. This was really part of the core thought behind the framework as well. How do we incorporate the standards of the web into the fundamental framework? The .NET framework supports HTML, obviously, XML to the absolute core, SOAP, XSLT, XPath, etc. And we will continue to support, we are a standards leader in terms of web services, in terms of web standards. We really think this is the way, as I said, that we're going to be interoperating. XML support is deeply embedded inside of the .NET framework. I'm going to show you a demo in just a second. It's going to show you just how deeply it is embedded inside of. And it's key to remember that the support for these web standards and web programming models really affects everything. It affects everything that we do, data access, base services, UI, you name it, it impacts it. So I kind of want to show you an overview of kind of the life cycle of the development models that we've had. One is the Win32 API, which I showed you an example of just a moment ago. And the next revolution on how people actually program the Windows was VB. When VB first came out, everybody was like, whoo, this is cool, right? I mean, because, some people kind of derided VB developers, but VB developers were laughing all the way to the bank, right? Because they were getting their job done a lot quicker than everybody else was, right? Because the key is you're trying to build applications. It doesn't matter how you do it, you just got to get it done, right? So VB really radically changed the development environment. And then you had MFC and ATL, and that radically changed the way C++ developers actually did code as well. Radically changed that. And then you had ASP, which was this web development model that was really extensible, really easy to use. People could just crank out web applications, right? Your boss came to you on Friday and said, hey, I need this done by Monday. Hey, no problem. I'll crank it out for you. No problem at all. So the .NET framework really takes those 4 programming models and unifies every single one of them. It has the power of rapid application development that is inside of VB. It has the subclassing and the expressiveness inside of ATL and MFC. And it has the stateless web service type architecture that's built into ASP as well. So it's a unification of all of those different programming models. And so the .NET framework really is composed of this base class library, ADO.NET, second generation of ADO, ASP.NET, and Windows Forms. And this sort of breaks out the actual namespaces, some of the things that are actually supported inside of the .NET framework. The base class library, you can see that it supports collections, I/O, net access, supports threading, security, all these different things that you expect from a base class library. Data is supported, ADO, SQL is supported, OLADB is supported. XML, wonderful support for XML inside of the .NET framework. Windows Forms, this next generation way of really building Windows applications or smart client applications. And then System Web, and that really represents this ASP.NET piece. And this is really, I'd encourage you, if you have a chance, to come to the ASP.NET talk, because we're going to talk about some of the power that's really available inside of ASP.NET. And so this is the functionality inside of the base class framework. You can see that it covers the whole host of things you typically would expect that you would need to utilize inside of an application. And all that's abstracted away for you and provided in a nice, clean programming model. And the same thing with the data in the XML. Very, very clean, very, very factored way of actually programming to it, whether or not you need to use XPath, XSLT, the serialization functionality. With ADO.NET, whether you need to access OLADB data sources or SQL server data sources, all that's built into the framework. And really quickly, I want to show you another demo, if I could, that actually shows you the depth of XML support inside of the .NET framework. So I'm going to I built a person object. Okay? So it's your typical person object that has an age, has an address, and has a name. And what I'm going to do is I'm going to prove to you how deeply embedded XML is. I'm actually going to create an instance of this person object. I'm going to populate it, and I'm going to transform it to XML like that. And I'm going to save it to the file system. And then I'm actually going to take that XML that I saved to the file system, and I'm going to read it back in, and I'm going to create that person object again. So let me scroll down really quickly, and I'm going to put a breakpoint here. And hit F5, my great debugging environment inside of VB. Not VB, but rather, this is C#. Okay, so I'm going to create a person object, incidentally, whose name is Doug. And I'm going to give it the name Doug Purdy. That's me. And I am 30, and that's a very frightening thing for me, because now I can't trust myself. And I'm going to create an address instance. I'm going to put Microsoft Way inside of that, and Redmond, and the zip code. And then I'm going to give that address to myself. So I have person object, address, populated that. Now I've got a full person object. So now what I'm going to do is I'm going to create a stream, a file stream that actually is going to represent a file sitting on some directory somewhere. And I'm going to call that Doug.xml. And then I'm going to create an instance of an object called a formatter. And this is a very extensible mechanism inside of the framework that can take any memory representation and transform it into anything else. Well, this formatter takes an object representation, or a person, and will transform it into XML for us. So I'm going to take that. I'm actually going to serialize that. You can see my window will pop up. And then I'm going to close that stream. So now if I navigate over here, and I actually look inside of Doug.xml, you can see this file has been created for me. I'm going to double click on that. It will come up. And looky what we will see. We will see the XML representation of that. If you look here on the screen, you'll see that you can see my name, Doug Purdy. You see that you can see my age. You see that you can see my address, 1 Microsoft Way. So I have taken an object and in a couple lines of code transformed it into XML. So now I want to read that in. So I've just destroyed Doug. If you look there, it says Doug is now gone. I set Doug equal null, and BB, this is like setting Doug to nothing. It just kind of eliminates Doug. So now I'm actually going to read that back in. So I'm going to open up a file, use the formatter to actually format from XML into an object, and then I'm going to print that out to the console. Just to prove to you that Doug is now back. And if you look here on the screen, you'll see that XML. So in essence, what I did was created an object, made it into XML, then read that XML back in and made it an object. So that's how deeply embedded XML is into the system. And that's called XML serialization. So this is what we think is really core. And you can do that with just about anything. No, that's not. That's actually the common type system takes care of that for you. You don't have to rely on serialization at all. Because at that common language runtime level, there is no distinction between languages at all. When you compile down to IL, every language compiles down to it. So the runtime system, it doesn't know what language it came from. No idea. This is sort of the features that you get inside of ASP.NET. We're running out of time, so I kind of run through that really quickly, but very, very full-featured. The best, what we think is the best web environment in the world to program in. Windows Forms, next generation Windows Forms programming, built in, wonderful model for developing smart client applications. If you haven't really looked at this, you have to. Terrarium is a great example of the power that you can have inside of Windows Forms.
Quick question.
Yes?
So are you saying all of the Windows functionality for thick GUI applications is encapsulated in the previous?
That's correct, yes. So all languages can utilize that. Okay. Speaking of which, a great transition into our languages discussion. We've got about 5 minutes left. So I do want to cover the languages. These are the languages that we're providing. So VB, C++, C#, JScript, J#, which is our Java language. All of those languages comply to a thing called a Common Language Specification. Common Language Specification, in essence, is a spec that says how one language will talk to another language, or how I can express something in one language that is readable by something in another language. At the end of the day, they all compile down to this IL code, but they all have to do it in a consistent manner. So all those languages you see at the top and all the other languages that are supported in the Common Language Runtime actually conform to this Common Language Specification. So because the .NET Framework is language neutral, you can leverage your existing skills. There is no need to learn a new language. You do not have to learn C# to run .NET Framework. No need. You don't have to go out and buy a new book unless you want to, right? Or go do C#. You don't have to do that. You're a C++ programmer, it works on the .NET Framework. You're a VB programmer, works on the .NET Framework. You're a Perl programmer, works on the .NET Framework. You don't have to relearn any skills. It just works. You can take advantage of all this great functionality. Two types of languages inside of the .NET Framework. I don't want to spend too much time on there, but it's called consumer extender. This just pretty much means can you add new functionality to the base framework, new properties, new events. And as I said before, we're providing VB, C++, C#, J#, and JScript, and over 24 languages in total. Standardization. Believe it or not, Microsoft is a firm believer in open standards. I know we get dinged a lot by folks who don't really think that we are. We have the only standards-based virtual execution system in the world. What I mean by that is this, is the CLI, which is a common language infrastructure, which the CLR is an implementation of that, is an ECMA, it is an international standard. Anyone can freely implement that. Anyone. And there are some attempts to actually do that. You're probably familiar with a lot of the high-profile ones that are doing that. That was ratified by ECMA on the 13th of December. And in essence, what this said was this becomes a international standard that is now being fast-tracked in ISO. So I wouldn't be surprised if very, very quickly you saw the CLI and C# being international standards at the ISO level. They already are for ECMA. ECMA is the organization, many of you are very familiar with them, that actually is a certification body for JScript, ECMAScript. This is also the same certification body that Sun sent Java to and then withdrew it. So C# is an international standard. That is very, very important to bear in mind. So when people talk about open standards, Microsoft is very compliant. In fact, we led the way with the way that you actually do that with the CLI and the CLR. And so that's actually based on the Common Language Runtime and its class libraries. So it includes the base class libraries and the Common Language Runtime. It does not include ADO.NET, ASP.NET, and Windows Forms, because those are value-add features that are very specific to what we're trying to do with the .NET Framework. So in summary, kind of just unwind the stack a little bit and talk about, hopefully what you guys saw here today. Number one, the point is the .NET Framework unifies all these different programming models. It unifies VB, C++, MFC, ATL, all the different ways you used to program for the Windows platform. All that is now unified. It dramatically simplifies the development cost. You don't have to worry about all that plumbing you used to have to worry about with COM. It's just gone. It's a very robust execution environment, built-in security. You're not going to have buffer overruns. You're going to be able to granularly control the way users actually utilize your applications. Supports multiple programming languages. You don't need to learn another language. If you want to learn one, great. There's 24 to pick from. But if you have one that's supported, you don't have to learn another one. And that really is a huge value add because you can reuse your skills. And then finally, XML web services. If you saw the example that I gave you just a few moments ago of actually serializing XML, you know that it's very, very easy to translate from this object-oriented, component-oriented world over to the web services world because we provide that support right in the box. Automatic transformation to XML, automatic transformation from XML to objects. We take care of all that plumbing for you. So in the end, we really think the .NET Framework provides fundamental core developer productivity. We think that it will really enable you to really move into this new world of web services and do it in the most rapid fashion possible. That's pretty much it, and I'll take some questions. Yep, go ahead.
So if you're building a team to build a really large application, you really don't care whether that person's a C++ programmer or a VB programmer, as long as they can write in one of the supported.
That's right. Absolutely. Yeah, we'll go here and then we'll walk back.
Do you have to recompile and go from 32-bit to 64?
Good question. Yeah, I'm sorry. Repeating the question. Do you have to recompile to go from 32 to 64? I don't know what our story is right now about that. Right now it's 32-bit only, and I don't know whether or not you actually have to recompile. I have a feeling no, but I'd have to check on that. And if you want, you can give me your card and I can get you an answer. Yeah?
It's C++ lets you do untype-safe things and have array overruns and have characters which are not Unicode characters. How can you support C++ in this environment?
Okay. The question was, because C++ supports unsafe things, supports the ability to have different string types, etc., how can you support C++ in this environment? The way that you support C++ in this environment is twofold. Number one, C++ runs as what we call unsafe code. And what that means is it can take advantage of all these services, but it's not verifiable. So it is conceivable that someone could actually access memory that they don't have rights to do that. Now, your system, by default, is going to lock that down. You actually cannot run unsafe code unless an administrator changes the security policy to enable that. So that is the way that the C++ actually can interoperate in that, take advantage of some of the unsafe features that provide a lot of power, but at the same time be locked down from administrators. So you can completely stop that code from running. But it will still interoperate in the same execution environment. Does that answer your question? Or okay.
Did you say that Terrarium was available at GOT.net?
Yes. Actually, not right now, because GOT.net is waiting till we launch, and then they're going to release a new edition of it. So I think they launch again on February 18th. I think this is the date. But if you go to www.got.net, you can go to /Terrarium. And I don't know if you can still download it. Worst case, they'll have a new version of it posted very quickly.
It's obvious you guys are going to this open platform and everything. And I was just wondering, with the JIT, do you see you guys going to where you would allow things to be JITted to other platforms besides x86, or is it always going to be x86?
The question was, will we support JITting to other platforms other than x86? The answer is categorically yes. And I'll give you a great example. We have a thing called the Compact Framework. Compact Framework is the .NET framework that runs on smaller devices. And so we already support jitters that actually JIT to, I believe, MIPS. We have one that JITs to ARM. So all those different processor architectures, absolutely. There's nothing that would prevent someone from going in and writing their own jitter. For alpha. Yeah, for any processor architecture you could write a JIT for. Absolutely.
For the mainframe?
Certainly. The question was, could you write a JIT for the mainframe? Absolutely. You certainly can. Yes?
Writing a JIT is really big. The most valuable thing you got there is the base map library. That doesn't run on the other platform.
Okay, well, I don't know if that's a question or a comment. Okay, the question was, will we make the base class libraries run on other platforms? The answer is yes. We have announced a shared source implementation of the CLI running on BSD, FreeBSD Unix. So we will have an implementation of the CLI that does run on FreeBSD Unix. Yes?
You said you could have multiple versions of software running next to each other. If I've got a program that uses version 1 of Class A, and I've got another program that uses version 2 of Class A. What happens when I pass objects between these two? I would think that one of them would wind up either breaking or not being tested properly with the version of the object you're seeing.
The question was, what if I have two applications? I assume this is a scenario. So I have application A, application B, and I decide to send instances of two different objects of different versions, of the same object, different versions between them. To answer your question, it will work. And the reason it will work is the actual type is specified by version. So if I serialize something, then it's actually version aware. So when actually something goes over the wire, it's actually two independent types. They may have the same name, they may look identical, but because they're different versions, they're different.
They're different, but now I send it across, the other guy can't use it.
The other guy could use it as long as he knew where that assembly was. Because the type loader will actually load that assembly if it's inside of the path that he can actually find it. So we have a thing called Fusion that will actually go out and search for assemblies. If it is reachable, it'll actually be loaded and used. Any other questions at all? Yes?
What's the advantage of C# over VB or C++?
The question was, what is the advantage of C# over VB or C++? Each language is targeted to a given particular developer. VB is really targeted at developers that are, number one, familiar with VB, number two, familiar with the type of syntax and I won't say robust, but the ease of use that you get inside of VB. And what I mean by that is if you just look at the way that you even structure methods, etc., it's very robust in terms of it's very verbose, right? There's no ambiguity in VB of exactly what's going on. There's no brackets. You don't have to worry about that. Where's this bracket linked to? Where does that bracket link to, etc. So VB is very good for programmers that like that environment. Now, there are very few things that VB.NET cannot do that C# can. A great example, there's two things fundamentally. There's other things, but the two main things that C# can do that VB can't do are two things. One is operator overloading, and VB developers, by and large, typically have not had to necessarily do operator overloading. And another thing is unsafe code. So the ability to actually manipulate pointers if you wanted to do that. You can do that inside of C#. Typically, most VB developers, they don't even care what a pointer was. But C# developers probably were developers who came from a C and C++ background who may want to manipulate pointers, who are very used to the fact that they could use operator overloading to achieve things. And so they're really targeted at different types of developers. So I don't know whether or not that answered it, but what we're trying to do is whatever your background is, we want to give you the programming environment that's going to be easy for you to be productive in. So if it's VB, VB.NET is definitely what you want to look at. If you need operator overloading or you need unsafe code, then C# is something you need to look at. So it's feature and what your past experience may have been. Yes?
Isn't there also some major performance differences depending on the language that you're using?
Okay, the question was, are there performance differences between different languages you're using? The answer is yes and no. Equivalent code, quote-unquote equivalent code, written in VB, written in C# will run exactly the same speed because they compile down to IL. Okay? Now, VB allows you to, this is another feature that VB has that C# doesn't have, it has late binding. So VB, I could start just sending random messages to type object. C# you could never do that. So obviously, late binded code is going to be much slower than early bound code. So if I'm doing VB and I'm taking advantage of late binding, it certainly is going to be slower than early binding. But if I did early binding in both languages, there should not be a performance delta at all. So you're correct in the sense that if I utilize features of a language that end up resulting in IL that is slower or more operations than what something more succinctly would be, then yes, there would be a performance delta. Yes?
What's the difference between J# and Java?
Question is, what is the delta between J# and Java? J# is close and dear to my heart. I actually run the J# EAP, the early adopter program for the developer division. The deltas are this. Java is two things. There's the Java programming language, which most people are very, very familiar with. So the Java programming language is really what J# represents for the .NET platform. So you can code in Java language syntax for the .NET platform. So if you're a Java developer, you just simply come over and just start coding Java code. Now, it supports, in addition to the fact that Java language syntax, it also supports the base class libraries up to 114. So you can actually code against Java lang object, Java lang string, Java vector, Java util vector. So if you want to code against those particular objects, you can still do that, and those will automatically be translated into, I won't say translated, those are actual .NET types as well. So Java lang object is a .NET type now inside of J#. And I believe, yeah, so 114 is that functionality that we have the base class library, and then it's the Java language on top of that.
So a Java programmer doesn't have to learn a new language to use.
Yeah, the distinction is, the question was, the Java programmer doesn't have to use a new language, learn a new language. That's absolutely true. So if you were a Java programmer that used to code, and you knew the base class libraries were 114. So you don't have to change anything. You can actually just move your code over. Yeah, we'll go in the back.
Who's doing the Perl implementation?
The question is, who's doing the Perl implementation? I think it's active state. Okay, one more.
System object, does it have a lot of state associated with it? Or?
Does system object have state associated with it? System object provides things such as hash code, provides the mechanism to transform itself into string. So it's just your typical.
More mechanism than state.
Yeah, I mean, well, it does contain state in the sense that I always need to, at least the algorithm, if I have to store state for, let's say, the hash code, it always needs to return the same value, right? So from that perspective, it may have to maintain state, but it's actually going to be something that extends system object that will probably hold the state for you.
Yeah, that's what I hope.
Was there? Yes.
Which version of the Java you took into consideration for J#?
Which version?
Yes.
It's JDK 114 is the base class library, and it's Java language specification 2.0. 2.0.
So how are you actually thinking of these issues, versioning issues and all? In future, if Java comes up with new version.
We are only going to support it this time. We have only announced support for 114. Obviously, if customers would like additional support, we're willing to listen to that. I obviously cannot agree to support anything greater than 114. Any other questions? Great. Thank you very much.
Thank you.